Hey guys, today we're going to learn how to solve a rational equation. Now, rational equations can be solved by either cross-multiplying, or if you have a rational equation added or subtracted with another, you would have to find the LCD, perform the operation, and then solve for x, which I'm going to show you how to do both. Now, when we're solving a rational equation, the first thing that we need to take note of is any excluded values. We saw that when we were graphing rational equations, we would have vertical asymptotes or holes, which always occurred when the denominator is equal to 0. So those would be your excluded values. Remember, when we would write the domain, we would always make sure to exclude any vertical asymptotes and any holes. So if I have this rational equation here, I would first look at the denominators before I solve. I make each of those denominators equal to 0 to solve for x. Those would be my excluded values. For this one, I'd have to add 5, so x cannot equal to 5. These should actually be could not equal. Over here, I would add the 10, so 2x cannot equal to 10. Divide the 2, and we get the same value of x cannot equal to 5. So since these are the same, that's fine. This is my excluded value. Now I'm going to explain why we do this first once we finish solving this equation. To solve this equation, we have 3x plus 7 over x minus 5 is equal to 5x plus 17 over 2x minus 10. In order to solve, since you just have one rational equation equals another, we can cross multiply. So we would do the diagonals is equal to the other diagonal. So 3x plus 7 times 2x minus 10, that's this diagonal here, could equal to this diagonal, which is x minus 5 times 5x plus 17. Now the order in which you multiply the diagonals does not matter. Like if you did x minus 5 times 5x plus 17 equals to 3x plus 7 times 2x minus 10 is the same exact thing. You would end up with the same answer. So now what we're going to do is we're going to try to solve. So first we have to distribute everything. So I'm going to distribute this 3x plus 7 with the 2x minus 10. And what I get here would be 6x squared minus 30x plus 14x minus 70. And that's going to equal to, now I distribute the x minus 5 to the 5x plus 17. 5x squared plus 17x minus 25x, because now I'm distributing the negative 5, minus 85. When we look at the equation, what we have here is a quadratic. And in order to solve a quadratic, we have to make it equal to 0. So we're going to combine these like terms first, and then we're going to move everything over to one side. So this is going to be 6x squared minus 16x minus 70. And that's going to equal to 5x squared minus 8x minus 85. Now we're going to make this equal to 0. So I'm going to move everything here from the from the right side over to the left. So I'm going to subtract this 5x squared over to the other side. I'm going to add the 8x, and I'm going to add the 85. And what I end up with is x squared minus 8x plus 15. And that's going to equal to 0. This is now a simple quadratic equation that we can factor. So remember, we're looking for the two numbers that would multiply to give you positive 15, but add to give you negative 8. And those two numbers are negative 3 and negative 5. Since negative 3 times negative 5 is that positive 15, and negative 3 plus negative 5 is negative 8. So that would give us x minus 3 times x minus 5 is equal to 0. Once you have it factored, you set each individual factor equal to 0. And we solve for x. And we get here two solutions. We get that x is equal to positive 3, since I would add the 3 over, and x is equal to positive 5, since I would add the 5 over. Once you have your solutions, before you can confidently claim what is the answer, you have to look at the excluded value. We see here that the excluded value is 5. So 5 cannot be a solution because it is an excluded value. This 5, that is called the extraneous solution. It is a solution that does not work, basically. Because in order for an answer to be considered the actual solution, it has to be defined by the graph, meaning that what defined means is that that particular point is on the function when you look at the graph. But at x is equal to 5, that's where we would have a vertical asymptote. So that particular point would not be a solution because the graph does not go through that point. So, like I said, x is equal to 5 is called extraneous. So this is not my actual answer. My solution would be x is equal to 3. So that's the difference between an actual solution and the extraneous solution. So, and I put it here, extraneous solutions are not solutions of an equation. Extraneous kind of sounds like extra. It's kind of like an extra solution that you get that does not actually work. Now let's look at another example where we would not be able to cross multiply. Here we have 2x minus 9 over x minus 7 plus x over 2 is equal to 5 over x minus 7. Because here we have an addition problem, this we would not be able to cross multiply because we would first need to be able to add this together and then you can cross multiply. However, there is a shortcut to that. But before I show you the shortcut, we have to determine what is our excluded values. So we look at all of the denominators and we see when these denominators would equal to 0. In this denominator, we have x minus 7. That means that if I set x minus 7 equals to 0, I would add the 7 and I get that x cannot equal to 7. This would be my excluded value. If I look at the rest of the denominators, this one is 2. 2 is never going to equal to 0, so that is not considered an excluded value. And this is the same denominator as before, so we just end up with the same excluded value. Now, let's move on to how to solve. First, we have to determine what is the LCD, since this is an addition problem. When I look at my denominators, my LCD is just taking all of those individual parts of the denominators and putting it together. So we have the x minus 7, and then we have the 2. We have another x minus 7, but since I wrote it here, we don't need to write it again. This is my LCD, 2 times x minus 7. So now what we do is we're going to multiply the entire equation by the LCD. The result will be an equation with no fractions. And this is what you're going to see. So I'm going to take that LCD, the 2 times x minus 7, and I'm going to multiply the entire equation. So 2x minus 9 over x minus 7 plus x over 2 is equal to 5 over x minus 7. What I'm going to do now is distribute. Now remember when we were multiplying rational functions, when we're multiplying 2 times x minus 7, that's just 2x minus 7 over 1. So when I distribute this to each of these rational functions, we multiply numerator with numerator, denominator with denominator. But don't actually multiply, and you'll see why. When I distribute this 2x minus 7 with the first rational function, I get 2x minus 7 times 2x minus 9 all over 1 times x minus 7, which is just x minus 7, plus. Now I distribute it to the x over 2, which would give me 2x minus 7 times x over 2. and that's going to equal to 2x minus 7 times 5 all over x minus 7. When you have distributed everything, think about when we were simplifying these rational functions. In this first one, we have this x minus 7 in the numerator as well as in the denominator, so they would cancel. Here, we have this 2 in the numerator as well as in the denominator, so those would cancel. And here, I also have this x minus 7 in the numerator as well as the denominator, so those would cancel. So now we write down what's left. Here we have this 2 with 2x minus 9, and then this would be over 1, which we never really need to write. So what we have is just 2 times 2x minus 9 plus x minus 7 times x over 1, which is just that. And that's going to equal to 2 times 5, which is 10. So now what we do is we distribute. And see how we ended up with an equation that no longer has any fractions. So this is now easier to solve. What we get here is 4x minus 18 plus x squared minus 7x is equal to 10. Now I can combine this 4x and this negative 7x, and that gives me x squared, because I want to write this in standard form, so I start with my highest exponent. 4x minus 7x is negative 3x minus 18, is equal to 10. This is a quadratic, so I can subtract the 10 from both sides to make it equal to 0. And I get x squared minus 3x minus 28 is equal to 0. Once you have the quadratic equal to 0, we're going to factor. So the two numbers that multiply to give me negative 28, but add to give me negative 3 are negative 7 and positive 4. So when I write out my factors, it would be x minus 7, x plus 4, and that's going to equal to 0. And if I set each factor individually equal to 0, I get that x is equal to 7 and negative 4. But remember, before I can state what is my solution, we look at our excluded value. We get here that x cannot equal to 7. So that means that x is equal to 7 is the extraneous solution. Since I did get it as an answer, but it's the excluded value, so it's not the actual solution. My actual solution is the negative 4. So x is equal to negative 4. Now this is important. You'll notice that we've gotten 2 answers every time. That is a possibility, however, it doesn't necessarily mean that you'll always get 2 answers. This is a quadratic, which is why we ended up with 2, but with only 1 solution. Sometimes you won't get a quadratic, and so you'll end up with only 1 solution. And if that one solution is the excluded value, then that means that there is no actual solution to that rational equation. So there's many possibilities, and it all depends on what the excluded value is and how many solutions you end up with. So let's look at a couple more examples. In this first one, we have 8 over x plus 3 is equal to x plus 1 over x plus 6. Now before we start, we need to determine those excluded values. If we look at our denominators, we now have 2 excluded values, because this one here would mean that x cannot equal to negative 3, and for this denominator here, it means that x cannot equal to negative 6. So these are my excluded values. Now let's work on solving this rational equation. Because here we don't have any operation like adding or subtracting, we can just cross multiply. So we have this 8 times x plus 6, and that's going to equal to x plus 3 times x plus 1. So now we're going to distribute this 8, and we get 8x plus 48 is going to equal to, we distribute the x plus 3 to the x plus 1, and we get x squared plus x plus 3x plus 3. Combine like terms here, we get 8x plus 48 is equal to x squared plus 4x plus 3. Now when we look at this equation, we have a quadratic. So that means that we're going to have to make it equal to 0. In order to make it equal to 0, I need to either move everything here from the right over to the left or everything from the left over to the right. Now I normally like to move everything to where the x squared is, especially since it's positive already. That way when I move it over, I would have a positive quadratic that would make it easier to factor. So I'm going to subtract this 8x over and subtract this 48. And we get that x squared minus 4x minus 45 is going to equal to 0. So I just reversed the order. I wrote this that's on the right over on the left, and this is 0, so I made it equal to 0. Now that we have a regular quadratic, we factor. The two numbers that would multiply to give me negative 45, but add to give me negative 4, would be negative 9 and positive 5, since negative 9 times 5 is negative 45, and negative 9 plus 5 is negative 4. So my factors would be x minus 9, x plus 5 is equal to 0. If I set each individual factor equal to 0, I get that x is equal to 9 and negative 5. Now I look at my excluded values. 9 and negative 5 are neither of these excluded values. Therefore, I actually have two solutions. These would be both solutions to that rational equation. And we would have no extraneous solutions. Now let's look at this last one here. We have 2 over x minus 3 minus 3 over x plus 3 is equal to 12 over x squared minus 9. Before we work this out, we need to make sure that the denominators are all factored. These two here don't need to be factored, but x squared minus 9 is x plus 3, x minus 3, since it is a difference of squares. Now I'm going to determine my excluded values. When I look here at this denominator, I get that x cannot equal to positive 3, and here that x cannot equal to negative 3. These two factors are the same as these two, so it's the same excluded values. So I have those two. X cannot equal to 3 or negative 3. Now, because this is a subtraction problem, this is that scenario where we would need to multiply the entire equation by the LCD. So we need to know what the LCD is. In this case, my LCD would be x minus 3, x plus 3. Since here this is the x minus 3, this is the x plus 3, and this rational function has the same factors. So that's my LCD. So now I'm going to take my LCD and I'm going to multiply it by the entire equation. And I'm going to use the factored version of this denominator. So we have to distribute this LCD. Now a little shortcut, if you don't want to write it all out like I did in the other example where we had to multiply the LCD, is we look at the LCD and what we're multiplying. If we distribute this x minus 3 and x plus 3 with the 2 over x minus 3, whatever is in the denominator would end up canceling with the LCD. So this x minus 3 would end up canceling with this x minus 3. So the only thing that I would end up multiplying is the x plus 3 with the 2. Minus, now we have to think about distributing the LCD to the next rational function. And I see that denominator is x plus 3, which would cancel with this x plus 3. Therefore, the only thing that we would multiply is the 3 with the x minus 3. And that's going to equal to Now if I distribute this LCD to the 12 over x plus 3x minus 3, the denominators would cancel completely with the LCD. So the only thing that we would have left is just the 12. So now that we have our equation, we're going to distribute and solve for x. So we have here 2x plus 6 minus 3x plus 9 is equal to 12. Now this is not a quadratic equation, so we don't have to make it equal to 0. Notice that these x's do not have an exponent. So the only thing that we're really going to do is just solve for x. So we want to isolate it. So first, let's combine like terms. We have this 2x and negative 3x, which would give me negative x. And then we have the 6 with the 9, and 6 plus 9 is plus 15. And that's going to equal to 12. Like I said, this is not a quadratic. We're just going to solve for x. So we can subtract the 15, and we get that negative x is equal to negative 3. Divide the negative 1, and we get that x is equal to positive 3. Now if you look at the excluded value, we get here that x cannot equal to 3. But this was my only solution. But since it's an excluded value, that means that this is actually an extraneous solution. Therefore, this particular rational equation, since this is not a real solution, would have no solution. So those are the three scenarios that you can have when you're solving a rational equation. Either you can have no solution, like in this example, because the one that you got was an excluded value. You can have two solutions because neither of these were excluded values. Or like in the other ones that we did, you can have one solution where one of the solutions that was given was an extraneous solution. And that's solving rational equations.